Hi guys. So our video for today is going to be pretty short because we really only have kind of two things to talk about quickly. So in your note packet, we're going to be on page number 6 up at the top where it talks about mole volume relationship. I'd also recommend have a handy dandy calculator handy. So we've already talked about previously this relationship between moles and molecules or moles and particles, right? That was where we had to use Avogadro's number, 6.02 times 10 to the 23rd. We then talked about the mole mass relationship where you had to actually find the molar mass of whatever compound it is you're talking about and use that to convert between grams and moles and grams. Today, we're going to be talking about the mole volume relationship. And this particular relationship exists because of something known as Avogadro's hypothesis. Now, Avogadro, again, was the gentleman who figured out that whole 6.02 times 10 to the 23rd thing. But here's what he said. Avogadro said equal volumes of gases at the same temperature and pressure will contain the same number of particles. So to explain what that means, imagine for a moment that you have 3 balloons. That's a balloon. That's a balloon. And that's a balloon. Okay. Now imagine that these 3 balloons are all at the same temperature, P, the same pressure, P, capital P, there we go, and the same volume. I'm fully well aware that I did not draw them perfectly, so they might look like they are slightly different sizes. They are meant to be the same. So assume that those 3 things are equal. If those 3 things are equal, that means they have to have the same number of particles. It doesn't matter that maybe this one has helium in it, and maybe this one is filled with oxygen, and maybe this one is filled with neon. It doesn't matter. It could be carbon dioxide. It could be water vapor. If you have equal volumes at the same temperature and pressure, they have to have equal numbers of particles. So what that means is at STP, and we've seen this a few times before, what STP stands for is standard temperature and pressure. If you look on table A of your reference tables, the very first table, right there, you can see we have standard pressure and standard temperature. They give the pressure to you in kPa in atmospheres. They give the temperature to you in Kelvin and degrees Celsius. It just means like in normal room conditions, you're not in any funky temperatures. You're not in any really weird pressures. Just like, cold, it's 0 degrees Celsius, but like just standard conditions. We're not talking about doing science in the middle of deep space. At STP, 1 mole, or 6.02 times 10 to the 23 representative particles of any gas will always occupy 22.4 liters. Always. So unlike the mass stuff that we just did, where mass changed depending on what it is we were talking about, with volume, it's a constant value. 1 mole is going to equal 22.4 liters, okay? Now, that is technically only true when we're at standard temperature and pressure, but for the purposes of this class, we are always going to be at standard temperature and pressure. So you can assume that 1 mole is equal to 22.4 liters. This 22.4 liters is known as the molar volume, okay? So let's go through and do a couple practice problems. Let's start with number 1. Number 1 says sulfur dioxide, SO2, is a gas produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.60 moles of SO2 gas at STP. So in the problem, you are told you have 0.62 moles, MOL. Get this back to the size that I want. Here we go. As always, start by putting that number over 1. Next, you are going to multiply that by a conversion factor turned into a fraction. Now our conversion factor this time is going to be this right here. Yay. So make sure that you set it up so that your units cancel, which means 1 mole goes in the denominator, 22.4 liters goes in the numerator. If you set this up correctly, your units should cancel. So mathematically, what I am doing, 0.60 times 22.4. You're going to get an answer in your calculator. My calculator gave me that. How do I round it? Well, look at your problem. The 0.60 has 2 significant figures in it. So I'm going to round my answer to 2 significant figures. It's just going to be 13 liters, okay? Always match your answer to the number that you're converting. I'm going to actually put equal sign there. And then it is helpful to put a box or circle your final answer. That's it. Just to do a problem that's going the other way, let's actually head down to 24. 24 says, how many moles are in 76.8 liters of carbon dioxide gas at STP? So I start by typing in 76.8 liters. I put that over 1 to act as a visual reminder that it's going to act as if it's in its numerator. I set up my conversion factor fraction, plug in your molar volume conversion factor, set it up so that your units are going to cancel. So in this situation, the 1 mole goes in my numerator, the 22.4 liters goes in my denominator, so that liters cancels with liters. So mathematically, what I am doing, 76.8 divided by 22.4 gives me that as an answer. I need to round it to 3 significant figures, which is 3.43. My unit on this is MOL. Okay. That's it. That's molar volume. I am going to upload the key to these other problems, so I would recommend maybe give those a try at some point. Let me know what questions that you have. So to summarize, at the top of page number 7, we have what's known as the mole roadmap. And here's the thing to kind of keep in mind. Anytime you are starting with moles, you are going to be multiplying in order to get volume, mass, or number of particles. So if we just go back into some of the problems that we've done, if you're starting with moles, we multiplied by 22.4. If we're starting with moles, we are multiplying by the molar mass. If we are starting with moles, so I scroll back through here. If we're starting with moles, we are multiplying by 6.02 times 10 to the 23. So if you start with moles, you multiply, okay? You can also follow the units and it'll show you that you multiply. If we are starting with something else and converting into moles, so if we're starting with volume and converting into moles, we are going to be dividing by 22.4. If we are starting with, we'll just say particles, whether that's atoms, molecules, formula units. If we're starting with particles and we're converting to moles, you are dividing by 6.02 times 10 to the 23. Actually, maybe I'll add that in here. 6.02 times 10 to the 23. And if you are starting with mass and you are going to moles, you are dividing by the molar mass, atomic mass, okay? Don't forget with atomic masses, you always want to round to the 10th place. All right, and that's it. That's it for notes for today. So when I see you in class again, hopefully what we're going to be doing is a bunch of practice where we're going to be doing all 3 of these. You're going to go from moles to particles, or you're going to go from mass to moles, or moles to volume. So just a bunch of mixed problems that we can kind of work through together just to get some additional practice with this. And that's it. All right, see you soon.